Okay, so this is basically our group, Ask Geology group, and today's the topic is timescale and cross reference. So basically, what is geological timescale? You know, the origin of universe is 13.6 billion year. Okay, then after that, what actually happens? Origin of Earth is around 4.6 billion year. Then after that, whatever the time scale we have the, like, if you do have some the record of your time scale after the formation of Earth, then that time scale we can just call it to be a geological time scale. Before the origin of Earth, whatever the time lapse, we don't have any like lithological unit, because geological time scale, if you just go to the definition of your geological time scale, this is basically, this is actually a record of your rock data. And before the origin of Earth, there was no existence of rock. Okay, so the time scale between this origin of universe to the origin of Earth, this time lag or time span, we cannot call it as a geological time scale. But we do have some evidences. Okay, we do have some evidences of the origin of the Earth, and this time lapse, whatever the changes, celestial changes has been happened, we do have some like extraction of some from the meteorites, isn't it? Then after that, your geological time scale starts from your after the origin of Earth, then evolution of Earth, and today's present day Earth. Okay, so basically what geological time scale is, so geological time scale basically is a representation of time based on the rock record of Earth. Okay, so if there is rock, okay, there are so many of succession of rocks with respect to time. Okay, and this time lapse, the concept of your time with the help of your rock record, that is basically your geological time scale. Geo means Earth, isn't it? Geo means Earth. So before this origin of Earth, before when Earth was not present, then that time scale before that, then we cannot call it as a geological time scale. And this is what actually geological time scale. This is actually a system of chronological dating. Dating means we have to find out, we have to determine the relative age of the rock formation or any kind of formations. Okay, so to date these different kind of geological units or the rock units, we use basically chronostratigraphy and geochronology. Chronostratigraphy and geochronology, those are basically similar things, but there is a very minute thin line of difference is there. Okay, chronostratigraphy basically it is the process of relating strata to your time. Okay, chron means time, and stratigraphy means basically the study of successive any kind of formation. If that is lithology, then that is lithostratigraphy. We will talk about these things later. Okay, and in geochronology, this is actually the scientific branch of geology which basically determines the age of the rock. That may be your absolute age or a relative age. Basically in geochronology you use the absolute age, that is radiometric dating, and there are so many of other dating types. Okay, if you have any kind of doubts, you can just interrupt in the middle of this lecture. Okay, no problem. So basically what actually stratigraphy is, it is the branch of geology and earth science that deals with the arrangement and succession of strata or layers, as well as the origin, composition and distribution of the geological strata. So basically it is telling that stratigraphy basically deals with the arrangement or the succession of your layers or strata. Okay, so there are so many types of stratigraphy you can see. I just told before that if you are just considering the lithology as the reference unit, then that stratigraphy will be lithostratigraphy. Okay, in biostratigraphy, fossils, we'll use the fossils for the study of biostratigraphy. Magnetostratigraphy, the magnetic polarity. Chemostratigraphy, chemical properties. Allostratigraphy, the presence of your discontinuities. Okay, seismic stratigraphy, that is basically, this is seismic stratigraphy and sequence stratigraphy. These are two very interesting and vast, these are developing discipline in the field of geology. Okay, in sequence stratigraphy and seismic stratigraphy, these two subjects are vastly used in oil exploration. Okay, oil exploration type, or they have very vast implications. Okay, they in seismic stratigraphy they use the seismic traces, and in sequence stratigraphy they basically use the depositional trend. And this sequence stratigraphy, this can also happen in case of your marine realm and in case of continental part. Okay, this sequence stratigraphy, it is like so many of concept of many students, they think that sequence stratigraphy is basically restricted to your oceanic part, but not the oceanic part. It is also, okay, it is also present in your continental part also. Okay, in continental you can see the sovereal unconformity. Okay, the presence of sequence stratigraphy, that will be a very different topic I will be covering later. So basically the what we told that the geological time scale, that geological time scale means we need our geo, means we need our earth. Then after that, whatever the formation, whatever the time lapse that just passed over many millions of years, then that is your geological time scale, simple. Okay, then before that, okay, before the formation of earth, there was also a time where the big bang happened, and there are so many of chemical changes, basically so many of nucleosynthesis types process they happened. Okay, there are so many of theories has been proposed for the for the evolution of your solar system, like the nebular hypothesis, planetesimal hypothesis, tidal double star hypothesis, or the binary hypothesis, meteorite hypothesis, protoplanetary hypothesis, and finally the big bang theory. And this big bang theory is the most accepted theory that is proposed for the origin of our solar system. And this big bang theory dates back, it's dates back long ago. Okay, and George, this is the name, you can pronounce whatever you just lambda something, suggested the big bang theory in 1920s. And you know, this person was a priest. This person was a priest, he was not a scientist, he was a priest. And when he proposed this big bang theory, there are so many of scientists who laughed at him. Okay, then after that there are so many of things came out from the big bang theory. Okay, and there are very much supportive. If you just see the elemental abundance, okay, elemental abundance in the atmosphere or the crust, how this crust mantle differentiated. Okay, what is bulk silicate earth, how this core differentiated from the mantle, how the cross differentiated from the core, and is there any relationship between these crossed mantle, core, the inner layers of your earth. And this big bang theory that minutely describes each and everything, but you cannot tell that this is the most appropriate one, but people are accepting this big bang theory. Okay, there are so many of criticism against this big bang theory also. Okay, so this is the chronology of the universe, the first the big bang, then after that Planck epoch. There are so many of little epochs. Okay, where you can see many types of, like, you can see that this is the inflationary epoch. You know, this is the universe expanded exponentially. Okay, this expansion then contraction, there are so many of phases of your expansion and compression, condensation. Okay, then hadron epoch, formation of hydrogen nuclei, how this hydrogen nuclei happened, and what is nucleosynthesis, what is big bang nucleosynthesis, which actually formed, which helped for the formation of this vast type of, like, your atmosphere, so many of reservoirs, atmosphere, your hydrosphere, cryosphere, everything. Okay, there are many 5 or 7 types of reservoirs present in the earth. Then photon epoch, then dark age, then finally reionization. So basically this is actually the big bang theory. You can see that this is the big bang theory starting point. Then after that, within the few seconds, okay, you can see that WIMP formed. What is WIMP? Okay, these are basically weakly interacting massive particles. These are massive particles. This big bang theory, this started with the concept of your singularity concept. Okay, what this singularity concept says, that there is one point, okay, which is very dense. Okay, very dense, and it has high magnetic property, that started like I cannot just say that it exploded, but it started growing. Okay, this, then after that, this big bang theory, this is not like the thing that it exploded, but someone says that it explodes, but the thing is that it started expanding. That's actually the concept of your big bang theory. And after that, you can see within the few seconds, okay, hydrogen, helium, neutron and proton form. This is quark soup, that is the quark epoch we just see in the last slide. Okay, then after that some atoms formed. Okay, then fast formed star, then formed galaxies, then in intergalactic gases, then cluster of galaxies form. You can see that 13.7 billion years, that is the age of your universe. Okay, from the concept of your singularity, and there are so many of phases. Okay, if I just tell each and individual thing, then it is going to be a very long lecture. Okay, so you can see that, okay, this, from this singularity, concept of singularity, to the formation of your universe, and finally to the formation of earth. Okay, then what are the uses of meteorites? We can use the data we just get from the meteorites to date the time which is present beyond the, before the origin of your earth. Okay, because before the origin of earth, okay, sorry, someone is joining. Actually, before actually the origin of earth, okay, this earth is basically a celestial planet, isn't it? Our solar system all has been formed from that gaseous nebula, and these are the remnant parts of our solar system, or these are the remnant parts of your universe. So by using the like chemical composition, there are so many of properties which may be similar to the meteorites, and that composition may be some representative of your earth system. Okay, like if what is the concentration of we basically use the rubidium strontium, there are so many of dating method. Okay, so these meteorites are the remnant part of our primordial part. Okay, and they are basically the signatures of our present earth structure. You can see the iron meteorites, okay, then the stony meteorites. There are so many of types of meteorites which are basically representative of the internal structure of earth. Okay, iron meteorites, you will be seeing that nickel and ferrum, those are very prominent. Okay, why? That actually basically we'll see the goldsmith classification of your elements. Okay, nickel very dense, condensed inside the core. Then after that, some sulfides, they just form the mantle. Okay, there are so many of stony meteorites. They represent the terrestrial basalt which are found in our earth. Okay, there are so many of similarity between our earth and our moon. Can anyone tell what is the age of your moon? Anyone have any idea that what is actually the age of your moon? What is the age of your sun? Okay, so the age of your moon and age of your earth, very similar. After the formation of earth, the formation of your moon happened. Okay, around 1 million year or something, 100 years, like this type of difference is there. If the age of earth is 4.6 billion year, then age of moon is 4.5 billion year. Okay, so, and you can see there are so many of chemical differences between the earth composition and solar composition. We just say lunar basalt. Okay, lunar basalt, but this lunar basalt is very much dominant on the moon surface, but that is not prominent in earth surface. Okay, because earth, what is the basaltic composition of earth we just get from the magma, mantle, the asthenosphere, the composition is very different. Okay, though they are formed from the same parent material, then how these differences are there? And is there any possibility if there is some differentiation assimilation concept? Okay, and we are geologists, and that's our duty to study these things and just cross reference these things. Okay, then after that, there are so many of types of meteorites. You can see iron meteorites, stony meteorites. Okay, stony iron meteorites. These stony meteorites, these are prominent. Chondrites, you will be studying about chondrites. So it will be a very different class. I will take this class also, or the geochemistry class, and they will cover this part. Okay, then how these meteorites or this primitive mantle, whatever you just say, the chondrites normalized, you can see that when we use this type of diagrams, okay, isotopic dating diagram. Okay, so you can see that we just use the rubidium strontium. There are so many SMND, so many of radioactive isotopes we use. Okay, so what are the implications of these things? You can see that from this point it is saying that evolution of RB depleted mantle, or this is the evolution of continental crust. that implies it is what actually it is trying to say. If our like whatever the data we just get, if it is falling in this line, then we say that it is actually coming from the crust, or if it is falling in below, then we are just telling that it is from the depleted mantle. So how? Okay, how? You can see that this is chondrite meteorites. Okay, this is basically normalized value, chur. Okay, these are basically one very interesting, these are actually scales, or these are the reference points, reference things from which we just measure. And from where this chur has basically, it has one component like value, numeric value. Chondrites, meteorites, or the primitive mantles, they have some specific values. Okay, from where this value this came, and why we are just comparing these value to our earth system, because these chur and these chondrites, meteorites, or the depleted mantle, whatever, these are basically from the chondrites. Okay, and why you are just taking these chondrites, or these chondrites is just stony meteorites, these chondrites, these are stony meteorites. So why we are using these things? This is the implication. Okay, you can see this is, if this middle point you are taking ND and SR. Okay, SMND and RBSR, but we just crossed the ND and SR. Okay, this is the cross plot. You can say this is a cross plot, and after cross plotting we can say that this bulk, this middle portion, this is the cross cutting point. This represents your BSE, this is your bulk silicate earth. And what is this bulk silicate earth? Bulk silicate earth basically represents your crust and mantle. Isn't it? There are so many of interesting things we will be covering in this session. So after that, the formation of earth happened. Whatever the like process they just occurred, like just we say that evolution of mother earth, that has already happened. And there are so many of layerings. You can say that crust, mantle, and core. You can see that this is the asteroid belt. Okay, and these are the remnant parts from where all the planets on the solar system has been basically developed. Okay, these are the remnant parts of the celestial bodies. You can say that. Okay, so Earth's layers, you can see, you know that crust, mantle, core, and there are various types of cross: continental cross, Sigma type, mantle, upper mantle, lower mantle, core, inner core, outer core, middle core. Someone also say that middle core. Okay, and by the use of this trace element, not only the trace elements, these elemental differences we can use. Okay, these asteroids, what are the meteorites, the concept of meteorites, we can use these things to study the differentiation of your core mantle crust, how this development of continental crust in the earth surface, or the development of mantle, or the development of core, we can correlate. Okay, we can correlate these things very clearly with the help of your meteorites. Okay, this is actually what, this is the date before the presence of your earth. Okay, these are the implications of meteorites. To date back when the earth was not present. After the earth formed, then whatever we just say, that is your origin of earth. After the origin of earth, that is your geological time scale. Okay, geological time scale. We can see that there are so many of creation of elements. This is basically the concept of your nucleosynthesis: Big Bang nucleosynthesis, stellar nucleosynthesis, explosive nucleosynthesis. Okay, galactic, that is your cosmic ray spallation. In this each and individual like synthesis, this concept, they minutely define how the formation of your elements that happen. Okay, the light elements, the heavy elements, the LRE, HRE, and the evolution of your periodic table. Okay, this is bulk silicate earth. I just remember BSEG, like bulk silicate earth geology. So B for Big Bang nucleosynthesis, S for stellar nucleosynthesis, E for explosive, and G for galactic or cosmic ray spallation, CRS. Okay, and this is actually your geological time scale. After the formation of earth, after the formation of your continental crust, various differential the differentiation process that gave rise to the formation of your crust, mantle, and core. Then after that, when the rock is there, okay, when the rock is there, then you can just trace the time with respect to your rock units. That is basically geological time scale. You can see that from the starting from the Archean, Proterozoic, okay, Phanerozoic, then Phanerozoic. Okay, you can see that this is Archean part. You can see that this is Eon, Eratham system. All of you know, like whatever, whoever are present, all know these things actually. What is Eon? What is Eotham, Eratham, system, period, series, epoch, stage, age, everything you know. So I don't need to just talk these things more. But you can see that from this is actually the geological time scale from the starting from the Hadean, then Archean, then Proterozoic, then Paleozoic, Mesozoic, Cenozoic. Okay, this quaternary, tertiary, this tertiary actually it has been deleted right now, because you can see that here this is the updated part, International Chronostratigraphic chart. Okay, you can see there is some Greenlandian, okay, Meghalayan. So these are some stages or ages, very minute part, okay, smallest part of your Eon, Eratham, this type of series. Okay, so Meghalayan, actually one of our professor, he was working in this session, working in this region, not in this region, he was a team of this Meghalayan. They have some speleothems. Okay, they have got some speleothems. With the help of that, they just got some newer ages. Okay. Okay, someone is also joining. So this is basically geological time scale. Up to here, anyone have any kind of doubt, or anyone just want to ask anything, you can please ask. Then I have or some next sort of five to six slides I'll be covering in a very faster way. So if up to here, if anyone have any kind of doubt or any kind of questions, then you can ask me, then we will proceed. Nothing. Nice. So let's go ahead. You can see this Archaeozoic, Proterozoic, then comes your Paleozoic. Age, you have to simply remember the age. Okay, and with respect to this geological time scale, I will be covering your stratigraphy part and the ore geology part, in which I will be only referring to the geological time scale. Okay, for example, if I just say this Carbonaceous, this is Carbonaceous, this is age of amphibians, when the amphibians came. Okay, what actually happened for the Carbonaceous? What is basically, this is very small now. Okay, so I am just telling you, just listen these things. What is basically Carbonaceous, and what is this from the ore geology perspective of view, what is the importance of this Carbonaceous time? You can say that this is the age of amphibians. That's also correct, no problem. This Carbonaceous, this is actually the formation of what climatic change happened. Okay, and you know also that this Carbonaceous age, that is very much important for the formation of your coal deposits from Carbonaceous to Carbonaceous to Permian, isn't it? Jurassic age, all of you just might be just looking the web series Jurassic Park. This is basically about the dinosaurs. Okay, and what are the various types, and Jurassic, after that Cretaceous, and there was a mass extinction event, and what are mass extinction. Okay, these are the geology and the lithology. The lithology and your biology means your fossil content. Fossil content is basically, it is the most appropriate, this is the most appropriate age determination tool. Okay, if you are getting some like some fossils, microfossils, even microfossils, they will come like foraminifera, these are things in Cenozoic quaternary period. Okay, you can see this Archean. Okay, I will just tell you one thing, how to memorize these things. Okay, this is important, that is actually basically important. So in Archaeozoic and Proterozoic, you will be seeing some, here you can see that Eoarchean, Paleoarchean, Mesoarchean, and Neoarchean. So better to we just say that say that EPMN, Eoarchean, Paleoarchean, Mesoarchean, and Neoarchean. And EPMN, this is also similar to your EPMA, which you will be using for the your trace element analysis. EPMA. Okay, IPMA, we just call it also IPMA. So for remembering the Archean, this is EPMN. Then this Paleozoic stage you can see in Paleozoic there are Ordovician, Cambrian किधर गया बे? अरे ये थोड़ा गलत हो गया है. ओके, सो Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. This is a little bit some mistake. Okay, so Cambrian, then Ordovician. Then what are the climate change, the sea level fluctuations? There are so many of interlinking of these your phenomena. Okay, in Carboniferous, global like snowball Earth. No, not snowball Earth, but everywhere, like your glaciers, snow covered area. That was the most prominent. That was very interesting for the formation of your coals, isn't it? Triassic, Triassic of Spiti, Jurassic of Koch. There are so many of things. Okay. And now we just exceed. So for this Paleozoic, that is there is one formula, that is cos dCp. COS cos dCp. You just remember cos dCp. For the Archean time, what you just remember EPMN. Then for the Paleozoic you just remember cos dCp. कोई तो एक dCp है, dCp you know, जो पुलिस में होता है. This is cos dCp. खत्म. Then Triassic, Jurassic, Cretaceous. This is very easy, you can remember. Then this Quaternary and Tertiary period. Tertiary is not present right now in the geological time scale. So you can see PEOMP. You can remember from this type of things. Okay. Paleocene, Eocene, Oligocene, Miocene, Pliocene. Then for the recent Holocene, Pleistocene, HP. Okay. So this is, I just used to remember these things. This is my formula, so you can make your own, no problem. This is basically the time scale. You can see that this is your 13.6 billion year. That is the age of your universe. Okay, age of the universe. Before that, this concept of the Big Bang, the concept of Big Bang, that actually started from the concept of your singularity. The concept of singularity, and the proposed Big Bang theory is proposed by a priest. से गोटे पूजारी थिले, बुझे ना, सी जेतेबेले कहले, sorry, he was a priest. So like when he proposed this Big Bang concept in 1920s, okay, in 1920s, there are so many of scientists laughed at him. Then after that, you know what, actually everything, whatever you just see, that is basically Big Bang theory is the most widely accepted theory for that defines, or that actually describes the formation of your Earth. Okay, formation of your solar system. So this is basically, then in Cambrian you see Cambrian, Ordovician, Silurian, whatever. You can see these are your pelcipods. This is fishes when Homo sapiens happened. Okay, Homo sapiens appeared. Then there are so many of life started from invertebrates to vertebrates, and there are so many of climatic factors. Okay, so this time scale, I just want to just tell you this time scale is very much important. Whatever you read in geology, like if it is the fossil content, or if it is like you just tell that Dharwar Craton. Okay, when this Dharwar Craton just came to existence, what is the age of your Dharwar Craton, or what is the age of your Bundelkhand Craton, or what is the age of your Singhbhum Craton, or Pandian Mobile Belt. So you have to remember if you just remember the geological time scale, then it will be very helpful for you to like correlate these things. Okay, I just say that Talcher formation in Odisha, present in Odisha, Talcher formation, that is from of Carboniferous to Permian age. Okay, and what are the climatic changes? These are the climatic changes. Okay, fresh water intrusion हो गया था उसमें. You can see some Jurassic of Koch, Triassic of Spiti. In the Himalayan region, you can see that so many of Buddhists, starting from the Buddhist history, you are getting the Miocene in the Assam self region. There are so many of stratigraphic sequences you will get. Okay, if someone says that what is the age of your Tipam formation, Tipam, you know, Tipam, that is the reservoir of your Assam Arakan fold belt. Assam Digboi, you know these things. Okay, the oil reservoir, what is the age of that Miocene or Pliocene, what is the age. If someone saying that I am talking about the Eocene time, then you will be very sure that what actually he is telling. Eocene means 56 to 33. This is, he is talking about the Cenozoic time. Mesozoic, Jurassic Park. I am going to this Jurassic Park. I just want to watch the Jurassic Park Part 3. So if it is Jurassic Park, then surely he is talking about the Mesozoic time. And what is the overall age? Maybe 65 to 250, 250. Khatam. Okay, what is the age of your हॉटी गोल्ड फील्ड? हॉटी गोल्ड फील्ड कब हुआ, क्यों हुआ? ठीक है, अभी तो एक वेरी इंटरेस्टिंग चीज़ ये है कि तुम्हारा BIF बैंडेड आयरन फॉर्मेशन, इट वाज वेरी प्रोमिनेंट बिफोर द 2.5 बिलियन ईयर्स एगो, बट नाउ वी आर नॉट एबल टू गेट दिस BIF. व्हाई? There are so many of interesting things. So this time scale, geological time scale, I will be covering the ore geology part and the stratigraphy part. That's why I am just telling that this geological time scale will be my reference for all the time. Okay. And after that you can see the continental drift, when happened, what happened. I just gave the example of your carboniferous, that coal formation. And this carboniferous coal formation, okay, you can see that the coal, whatever the coal is present in India, that the specific, even the proximate, ultimate, the physical and chemical properties of the coal we are finding in India, that is also getting in Australia also. And it was during the carboniferous time. So carboniferous में क्या हुआ था? मे भी कुछ हुआ होगा, आइदर साथ में हुए होंगे, तो एक साथ में तुम्हारा डिपोजिशन, सेम क्लाइमेटिक एनवायरनमेंट है, उनका डिपोजिशन हुआ है, देन दे ड्रिफ्टेड. The very interesting, the continental drift theory given by Alfred Wegener in 1912. Okay, so this is basically the present day. You can see the carboniferous, the supercontinent cycle will cover. Okay, this is basically representation, how you just remember. You can see the EPMN, COS, DCP, Triassic, Jurassic, Cretaceous, Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene, Holocene. This is the Cenozoic, this is the Mesozoic, this is the Paleozoic, and this is Archean. Then after that, that is Hadean. Okay, you can see the great, like this Alfred Wegener 1912, great. You can see this is, okay, this is the continental drift theory, Alfred Wegener. And this continental drift theory is very much important. You can you cannot just even imagine, in 1912 the science was not developed. Okay, there was no GPS, GIS, or there was no sea expedition programs were also there. And how beautifully he just derived these things. Okay, I'll be talking you very interestingly the history. Okay, how this, when there are so many of kings and queens, there are so many of kings who were princes actually, basically they were very much interested to explore the ocean. Okay, you know, Columbus, he just went somewhere else. And this India, by that time in history, okay, there are so many of, you can see there are so many of continents. These are the continents. And you know, that is very, this is actually the continental drift theory, sea floor spreading concept. Okay, mountain building process. These are some geological process. You will just come to know about these things very soon. You can see this is our India. Okay, I just want to tell you an interesting thing. You just see that this India, the velocity is very much increasing. In this part, you just see that the velocity of our Indian subcontinent is very fast as compared to the rest. When it is coming from this point to this point, that is fine. Then after this, you can see that is very high velocity, plate velocity. Okay, and these things happened before, after the formation of your crust. And when our Earth originated, then the origin of Earth, it was very hot. You know, the continental thickness was very less. You cannot say that in the Archean time there was plate tectonics because there was no plate during that Archean time. So it took some time for the formation of the plates. Then after that, the concept of plate tectonics came into existence, isn't it? So you can see these are the supercontinents. Okay, these are the supercontinents. This is Balbara, Ur, Caroland, Colombia, Nuna, Rudinia, Panotina, Gondwana, Pangaea. Pangaea is the most recent supercontinent. Okay, you can see that some major mass extinction event, end of Ordovician graptolites, Devonian trilobites in Permian. Very interesting, very important question. Maximum time it comes in exam in NET or GATE, both Triassic conodont and end Cretaceous ammonites. Okay, you can see the sea level changes curves. You can see this cos DCP, Cambrian, Ordovician. You can see that Ordovician, it was a like increase in your sea level, that is a simple fall. Carboniferous, it was high, then it suddenly decreased. Okay, Permian, Triassic, Jurassic, Cretaceous, you can see that Cretaceous time the sea level change was maximum. And this Cretaceous is very interesting. You can relate a lot of things from this sea level changes or this geological time scale, why this extinction happened. Okay, then glacial period, you can mark the glacial period from this, you can see. And this OM, this Paleogene and Neogene, this boundary is very much interesting. There are so many of, like in the recent part, there are so many of things even correlate. Okay, there are so many of mountain building process. Okay, you can see Pan African orogeny, East African orogeny, Greenville orogeny, and the importance of this orogeny to form these supercontinents. And you can very interestingly, I just you just remember that this UR or okay, this is your supercontinent that for another 3.1 billion year. Okay, and this the remnant part of your this UR or supercontinent, your Aravalli, Dharwal, Bundelkhand, Singhbhum, these are actually the remnant part of your Ur supercontinent. Okay, and how this they just measured by using the chronological data. Okay, and these are the things. Oldest rock 3.8 billion year, but they are just getting some 4.2 billion year old rock they are also getting. Okay, and origin of life around 3.5 billion year, sulfur based photosynthesis 3.4 billion year, oldest stromatolite fossils. Okay, first anaerobic organism, Cambrian explosion. You can see there is interesting 2.5 to 2.6 billion year, that was the period of rapid crystal growth. Why this rapid crystal growth? Okay, and what are the ice ages present? Okay, these are very interesting things. And in geological time scale, you just remember this geological time scale, the respective ages. Then after that we will just add on some these oldest rock. What is the age of earth, what is the age of your Singhbhum craton, we will just add of that at that particular time this might have happened or this has happened. Why? Because, and you know one thing, that geologist, okay, people say that geologists just talk in millions of years without any proof. But my friends, without proof, that is not science. And if we are just saying that the oldest rock is 4.2 billion year, then we do have proof. Okay, if someone asks that you are geologist, you just talk about hypothetical things, just say them that we do have proof. Whatever we are saying or whatever the geologist is saying, without proof that cannot be a science. Okay, so we are not storytellers. And you can see the index fossil. Index fossil, what is actually index fossil? That is the representative fossil for a short period of time and vast geological spread. Okay, that is your index fossil. We'll be covering these things later. Okay, individual things. And this is our earth, sorry, this is our India. You can see there are so many of Archean part. These are some Archean, some Proterozoic part, Proterozoic mobile belts. Okay, some Proterozoic mobile belts, some Purana basins. Okay, and some Cenozoic part, the Himalayan part. Okay, there are so many of these are the remnant parts. These are the remnant parts of your crustal evolution things. Okay, you can see that this Palvara, Ilgram, these are the Archean cratons, exposed Archean crust. In our India, that is your Dharwar craton, Eastern Dharwar, Western Dharwar craton, Singhbhum craton, Bastar craton, Aravalli craton. These are the Archean remnants. Okay, Archean nucleus which are being present. You can see this slave craton. Okay, this superior craton. There are so many of these things. Okay, and they have very much vast implications in your orogenesis processes. Then after that, we just conclude, save our mother earth. This is our motto. Okay, and thank you. This is our group Ask Geology. You can call to these numbers for more information, or you can just simply put a mail to this mail ID Ask Geology. What is the number you can see? Okay, so up to here, any kind of doubt, anyone, you can please ask simply, and you don't need to get worried about. Okay, I am a very free person, so you just continue. Okay. Subham Thavre, do you have any kind of doubt or any kind of how was the presentation, or Nutan Kumari, or is it some it is little bit informative or all